Good morning, everybody. Welcome back to Shadow Drawing. I'm doing a follow-up update on my laser case and laser project. So I ran into some issues with the 40-watt laser from Solvo, which is this baby here, due to the fact that this is a 40-watt laser requiring a minimum of 24 volts to power it. It won't even power on unless it gets 24 volts. Okay, so the issue that I ran into is the motherboard that is being used in this model frame kit only produces 12 volts. 12 volts. It has two connectors, 2-prong and a 3-prong, used for different types of lasers, but the maximum voltage output is 12 volts, and that's not enough to power the laser. So I tried doing a serial connection between the two voltage outputs to boost the two separate connectors, 12 and 12, to boost it to 24 volts, which theoretically should work. But the problem is there's a circuit on that board that does not allow you to do that. So that makes that board useless with a 40-watt laser. After doing research online, I was unable to find a Gerbil compliant control board. So then I decided, okay, I have a original Sovol 3D printer motherboard and the original screen with a dial. Before I did the update to touchscreen and the version 2 motherboard, which is the quiet board. So I thought, okay, well, what if I design this unit to run off of that? Because the Solvo boards put out a 24 volt current to the fan connectors. Unfortunately, there you're running into issues with not enough Y ports. There's only one Y port, so then I would have to do a splitter cable to come off of one port to power the two motors for the Y. And then once I wired all that stuff up, rough wiring, the control board, the screen wouldn't allow me to turn the laser on. So we ran into an issue with this. Research and people's advice on YouTube said that I could reprogram the firmware on it, but you know what, at that point, forget it. So I ended up scratching that part of it. So sometimes I try to overthink things and I go all these different directions. And so I had a epiphany this morning at 4:30 in the morning when I woke up, because it was really bugging me. A step-up transformer module. Why I didn't think of that in the beginning, I don't know. So I ordered a step-up transformer module. Basically what that does is it takes a 12 volt voltage and boosts it up to 24 volts. Now the one that I bought came with a dial and a LED screen, which has the way it's set up, it's like a dash mount. So you just mount it and you can go from 12 volts all the way up to 60 volts if you really wanted to by turning the dial in it. And it has that LED screen that shows you current, wattage, and all that stuff while it's in operation. So I ordered that, which should handle that situation. It goes up to 40 watts, and there should be enough wattage for the laser, and it's definitely enough enough voltage for the laser. So I ordered it. It was like $20. So I'm waiting for that to come in. It's supposed to arrive tomorrow, and I'll try that. I'm kind of hoping that'll work. The other option I did work with was to purchase a 24 volt power supply, and it will power the laser, but I have no control over it. So when you're doing certain prints or carvings, the laser needs to be able to turn on and off based on the software. And unfortunately, if you have a continuous power to the laser on a separate supply, the laser stays on consistently. So there's no way you can do any pictures or anything like that. It would work for cutouts because it's not really that big of a deal if the laser has to travel across the medium and you get a link burn from one piece to another, because basically when it moves to a new part, it's going to drag the cut over, but that's not a big deal because you're just cutting out parts. But that totally defeats the purpose. So, to the case. Now, in the first video you guys saw, I showed you the case. Okay, so what I have done is I made a change, and you can pretty much see it right there. I ended up purchasing a 12x12 laser filtration screen and the original one, which is down here, which is the 12x24. The plexiglass on the top is clear. Now, I thought about this, even though me personally, would look in here if I'm watching the laser, but then I thought to myself, there'll be a time where you're just going to walk up to it and you're going to look straight down into it, and you want to try to shield yourself from the laser and not take any chances. So what I did is I created this idea, which is a 45-degree angle plexiglass laser filtered glass or plexiglass, which basically is angled, so when you walk up to the case, it literally will shield you from the area in which the laser is printing. Okay, so let me just show you real quick on this. Get this thing off the stand. So now, normally when you would walk up to it, you could look in here and you would see the laser. So I ended up putting this heads up the screen type thing, so when you walk up to it, you can look down inside and watch the job, but still protect your eyes from the laser light. So I think that would be it was a cool idea, and it basically serves the purpose. Also, I built a control box, which is what you see here. Not done yet. Okay. This box was originally built for the Solvo motherboard to go inside. And then this piece, I just made it because I'm going to be using this case for the other design where the voltage control will be installed here, and then the emergency cutoff switch will be here. But initially, this box was made to fit the OEM SV01 LED screen, which fitted right onto here, and then it would have bolted, screwed in here and here to make it a solid piece, and that would have been the control for the Sovol design. But unfortunately that didn't work, so I've spent a lot of time on this, so I decided I'm just gonna retrofit this with a flat panel, as you can see here, which is going to have the other circuitry built into it. So at the top, it's going to be that step-up converter, which is going to go here with a dial. And then down here is going to be the emergency cutoff switch, which basically you could just hit it and it shuts off the laser in case, something goes haywire. So I'll be able to make use of that, so it's not a total waste of time and work. So basically, here's the completed laser case that I made. So now you can see it. Just going to do a quick open on this so you can see inside. There you go. It's all in there. And it is airtight to a certain point. All the joints on the box have been sealed with silicone. The door entry, where the door is, has been sealed with a felt piece on both sides, so it seals it. So technically, the only free-flowing air intake on this box is coming from this one little hole. Now, I won't know how that works yet until I actually start cutting. I'm going to do a burn test once I get it the way I want it. And if I need to add another one of these, I'll add it to this side. So you get kind of a Y air intake from the front, which then sucks the air out through the back. That should give me plenty of airflow to evacuate the smoke. I kind of designed it this way because I know a lot of people were talking about using a compressed air nozzle, which is mounted to the laser to blow away the smoke to give you better cutting. I might do that still, but at this point I'm gonna try this idea first, where it sucks clean air through the front, sucks it out the back. And if I can get a strong enough airflow going, then it should blow out the smoke from the area of where the laser is cutting. So we'll see how that works. Worst case scenario, I'll just add a pump to it. So anyway, this is my laser project, everybody. If you have any input or you want to add anything or you want to voice your opinion, any suggestions, I would always appreciate it. If you have any questions, feel free to ask. I will try to get back to you as soon as possible, and we'll see how this works. All right, guys. Take care. Stay safe. Shadow Drone out.